Hi guys. Today we're continuing with multiplying rational expressions. And today we'll put adding and subtracting in our fractions. So we have to factor. Remember, the very first thing you should do as soon as you see any kind of adding or subtracting is factor. Make sure that you are not canceling first. I've got a picture up here that shows someone who canceled out some x squares. That is not correct. That is not accurate. And if you are doing that, I can't even give you any points on these problems. Like that's an instant zero, no partial credit, nothing, because you didn't factor. So make sure that you're factoring first, and that when you are canceling an adding or subtracting problem, that you're canceling the entire thing and that you're not canceling out the parts. Here is our first example. Now, because we're doing multiplying now, we're going to have two fractions, which means potentially there are 4 different places that we might need to factor. Now, you only have to factor where there is adding or subtracting, but you should check all 4 places just to make sure that you're doing all the factoring that you need to be doing. So the first place that we're going to check is the top of the first fraction. Now, there is adding happening on the top of the first fraction, but I can't factor it. There's no GCF. It's a binomial, but it's not a difference of squares. But the fact that it is an adding problem means that I cannot cancel out the parts of it. And so I want to surround that m plus 3 with some parentheses so that it is all connected together. And it's just a visual reminder for me that, hey, I can only cancel out this m plus 3 with another m plus 3. I can't cancel out the m. I can't cancel out the 3. It's all or nothing. Moving on, the bottom of that fraction does not have any adding or subtracting, so I don't have to factor, and I don't even need to put parentheses because there's no adding and subtracting. So if you have a monomial, then you can just leave it be and do not put it in parentheses. Same thing with the top of the next fraction. 20m squared is a monomial. I do not need to factor that. When I get down to the bottom of the second parentheses, I do have adding, so this is a factoring problem. This is a trinomial, so I should be doing Xbox. I need 2 numbers that multiply to make 15 and add to make 8. And those are 5 and 3. Now, since there was nothing in front of the m squared, I can go straight to my parentheses. One of them is an m plus 5, and the other one is an m plus 3. When you are doing your factoring, remember that the main goal of these problems is to get something to cancel out. So it's really, really good that I got an m plus 3 for my second factoring because I already had an m plus 3 in this problem. So that was a really good sign that I did my factoring correctly. Once you've factored as much as possible and thrown parentheses around any adding or subtracting problems, then you can cancel. When you are canceling, it just needs to be one thing from the top of a fraction and one thing from the bottom of a fraction. They could be on the same fraction or 2 different fractions. That doesn't matter as long as it's one from the top and one from the bottom. In this problem, I have some identical parentheses. The m plus 3's can cancel. Please notice that I am canceling out the entire parentheses. I'm not canceling out the m's and then canceling out the 3's. For my m plus 5 parentheses, I don't have any other parentheses to cancel that with, so that will definitely be part of my answer. Now, my monomials that had no adding or subtracting, that were just a multiplication problem, and I did not put parentheses around them, those we can simplify like we were doing yesterday. So if you have something that is not trapped within some parentheses, then you can simplify the pieces of it. Like I can do 20 divided by 5. And I can do m squared divided by m. So if they are not trapped in parentheses, then you can just simplify the parts. When you're done, you need to write one single fraction. So the things that I have left over on the top are a 4 and an m, and on the bottom I have my parentheses m plus 5. If you want to keep the parentheses around it so that you're not tempted to cancel out those m's, that's totally acceptable, right? So I'd rather have you put too many parentheses than not have parentheses and accidentally cancel something that you're not allowed to cancel. All right, I have 2 more examples for us just to make sure we fully understand. Okay. So on this example, very similar to the one we just did, I have an adding problem that cannot be factored, but I am going to still throw some parentheses around it. I have 2 things that are monomials, so I will not be factoring those, and I will not be using any parentheses on those. Now, on the bottom of my second fraction, this is a difference of squares. For a difference of squares, you write 2 parentheses, you square root each number, and you do one with a plus and one with a minus. So that will turn into an x plus 6 and an x minus 6. Just like our previous example, I'm going to cancel out my x plus 6's. I'm going to simplify my 8 and my 2, and my x to the 4th and my x squared. For my final answer on this problem, I get 4x squared over x minus 6. And again, the x's cannot cancel because the bottom x is part of a subtracting problem. Same thing with the 4 and the 6. Since the 6 is part of a subtracting problem, I'm not allowed to simplify it. Okay, last example for today, and we'll do some practicing during class as well. In this example, I'm multiplying a whole number by a fraction. So if this ever happens, I do recommend that you don't leave it a whole number. You should make it a fraction. So every whole number is a fraction over 1. This will just help you identify your numerator and denominator a little bit easier. So I'm going to change that first part to 3x plus 3 over 1. Now 3x plus 3 can be factored. That has a GCF of the number 3. So I am going to factor out a 3 from that first part. This is the numerator, so it goes on top. And again, we're going to put a 1 on the bottom. On top of my next fraction, I have an adding problem that cannot be factored, but it can still just stay an adding problem, and we're going to throw some parentheses around it because it's adding. Now, based on the parentheses that I already have up here, a 1 and a 4, when I'm going to factor this and I'm thinking of 2 numbers that multiply to make 4, I'm probably not going to use 2 and 2. Because remember, the whole goal of this problem is to have things cancel out. And since I don't have any x plus 2's up here, I'm probably not going to get any x plus 2's on the bottom. And so I'm going to think a little differently, right? Not 2 and 2, but actually 4 and 1. And that's great because I actually have a 4 and a 1 on top as well. So 2 numbers that multiply to 4 and add to 5 are 4 and 1. Here, again, I can cancel my x plus 1's, 1 from the top, 1 from the bottom. And then even though my x plus 4's are on the same fraction, like that's fine. That's like the first part of this chapter that we learned, right? So as long as there's 1 on top and 1 on the bottom, you can cancel them even if they're on the same fraction. So basically everything is canceled from the denominator. I do have the number 1, but the number 1 does not need to be written. If everything in the denominator has canceled out, then you no longer need to write a fraction for your answer, and you can just write it as a whole number. The only thing that I have left over is the number 3. If literally everything from the whole problem cancels out, then you would write a final answer of 1. So remember, this is a division problem. So if we are dividing something by itself, it does turn into the number 1. So you will not be writing the answer of 0 at all for this chapter. If everything cancels, it's a 1. This concludes today's only video.